Okay, hello. Hello everybody. We are going to be continuing with lesson 2 in this video, which is factoring simple trinomials. So what is okay, first we'll remember that factoring is the opposite of expanding. So this is kind of what we're going to be doing in simple trinomials. Is here we see, if you take a close look at all our answers we got when we expanded binomials, which is 2 times a 2, we always got a trinomial answer. This was 3 different terms. We had an x squared, x constant, d squared, d constant, a squared, ab, b squared, x squared, x constant, that kind of thing. And again, x squared, x constant term. What we're going to be doing in this lesson is actually going backwards. We're going to be going from this form back to this form. We're going to be going from our trinomial to our 2 binomials. So we're going to be factoring it, which is again the opposite of expanding. So we're going to work with simple trinomials, and simple trinomials come in the general form ax squared plus bx plus c. So the same form that we saw, x squared, x constant term, where a equals 1. So this specifically is trinomials of this type, and where did my tick go? I'm having technical difficulties. Hold on a second. Oh no, my computer froze. All right, sorry about that. I had to restart something, but where was I? Yes, this one. And you can see here that because in front of the squared term, here we had a d squared, a d term, a constant, the d squared had a coefficient of 1. X squared, x term, constant, the x squared had a coefficient of 1. You'll see in these cases, the x squared term did not have a coefficient of 1. A squared, not a coefficient of 1. These two obviously don't have a coefficient of 1. And so these are not simple trinomials. These are what are called tricky trinomials, and we will get to that in the next lesson. So right now, we're going to be just factoring the simple one where the x squared term equals 1. So let's take a look and refresh our expanded form. Again, we're using the distributive property, the crab claw, or the rule here. So x times x, x squared, x times negative 7, negative 7x, plus 5 times x is plus 5x, and 5 times negative 7 is negative 35. So I will write the final answer, but this step is really the key to what we're doing here, because our final answer is x squared minus 2x minus 35. So ideally, our goal for now is to go from here back to here, correct? That's what we want to do. We want to factor our expanded form. So now we know how to go from a factored form to an expanded form. We want to go from an expanded form back to a factored form. And we'll look here. So it's easy to see where the negative 35 part came from, right? So I got the negative 35 because I did 5 times 7. So that's kind of fairly intuitive to kind of see there. And how did I get the negative 2? I did negative 7 plus 5, right? So these two numbers here, I mean, this x squared term will always be 1, right? Because that is our definition of a simple trinomial. We're only working with coefficients of 1 in front of the x squared. So the two numbers that we really have to be concerned with are the x term and the constant term. And we can see here how our numbers in the expanded form relate to the numbers that are inside the brackets. Really, we see here that this constant term has to be the two numbers that are multiplied with each other, and this x coefficient has to be these two numbers added together. So we can clearly see how we're getting these numbers. So in summary, when looking for factors for simple trinomials, the second terms in the binomials must can write this either way. We're going to say add to b. What is b again? The coefficient of the x term. Plus 5 minus 7 has to add to negative 2. And they have to multiply to c. And what is c? C is our constant term in our expanded form. Plus 5 times negative 7 gives us negative 35. So again, also recall that you can always check your factored form by expanding it back to see if we get the same trinomial. So let's try and factor. So again, we're looking, again, when we have a simple trinomial where x equals 1, we can start off by automatically putting something like this. This is what our thing is going to look like. By thing, I mean our factored form. It's always going to be x plus something or x minus something, and there's two binomials here that we're going to multiply to get our trinomial. So we're looking for two numbers that, remember, add to 11, add to positive 11, multiply to negative 30. So this is where you kind of have to do some guess and check work. We need two numbers that add to 11 and multiply to 30. So you have to somehow find these two numbers. The easiest, if you want to go the brute force method, is always start with the multiplication. Whichever way you're doing it, I recommend looking for the two numbers that multiply to 30 first and see which pair add to 11. So if you want to do 30, you start with 1 and 30. Those don't add to 11. 2 and 15 don't add to 11. 3 and 10 don't add to 11. 4 doesn't go into 30. 5 and 6. 5 plus 6 gives us 11. So plus 5 plus 6, because the two numbers are positive 5 and positive 6. So I put the plus 5, I put the plus 6, and we can see here, check. We're not checking this one, but we'll check anyway briefly. X times x is x squared, plus 6x plus 5x gives me plus 11x, plus 5 plus 6 is positive 30. When it asks you to check, and you have to actually show me your work, I just quickly drew some arrows there. That's not an actual check. You actually have to, write it out and check your work. But hopefully we're not going to do that because we're, lazy. So again, it's okay. So first thing I see is I see a trinomial. So I know I have to factor it a particular way. And now we're going to look for, okay, let's see, is it simple or is it tricky? The coefficient of the x squared is 1. It's a simple trinomial. I can start off by doing this. I'm looking for two numbers that multiply to give me negative 28 and add to give me negative 3. Now, whenever you see a negative sign, I should have mentioned here, whenever you see a multiplication that's positive, your two numbers can either be both positive or both negative. So keep that in mind. So whenever you have a positive multiplication, I am looking for two numbers that add to give me my my b value. However, we see here that we have a negative 28. So one of my numbers is positive. The other number is negative. And this is going to be very important because now I'm technically subtracting the two numbers to get me a negative 3. So let's see, negative 28, there's not very many options there. 1 and 28, 2 and 14. They don't subtract to give me 3. What else is there? 4 and 7 do subtract to give me 3, but I have to put the negative in front of the 7. Why is that? Because if I do plus 4 minus 7, only then will I get negative 3 as my answer. So you got to make sure the signs match up too. And again, this is why it's always good to start with the multiplication, because if your multiplication is negative, you know that you're looking for a subtraction to give you negative 3. That is, the two numbers will have opposite signs. If your multiplication is positive, the two numbers will have the same signs, either both positive or both negative. So you're looking for an addition to get you to the b or middle or the coefficient of the x term. So here my two numbers are plus 4 minus 7. Let's check this by expanding. X times x is x squared. X times negative 7, negative 7x. Positive 4x, negative 28. Combine like terms, x squared minus 3x minus 28. And I have verified that I have a correct answer. All right, let's pat ourselves on the back and let's continue forward. Again, the idea is we're going to get fairly good at these kinds of questions. But the simple trinomial is really like the simpler part of this factoring. So hopefully we'll see that it's not too complicated what we're doing here. So again, we see that this is a simple trinomial because there's a 1 in front of the x squared. Xx, nice and easy. Let's look for two numbers that multiply to negative 50. So as soon as I see negative 50, I know that my numbers will have opposite signs. So one of them is going to be positive, one of them is going to be negative, and they have to then subtract to give me my middle coefficient, or the positive 5 here. So let's see, what numbers multiply to give me 50? I have 1 and 50. They don't subtract to give me 5. 2, 25 don't give me 5. 3 doesn't work. 4 doesn't work. 5 and 10. Oh, they subtract to give me 5. And again, you have to kind of hopefully see that now the 10 is going to get the positive, the 5 is going to get the negative, because if I do negative 5 plus 10 or 10 minus 5, I get positive 5. So you're looking for that kind of thinking here. So I do x minus 5, x plus 10. And again, if we expand, we'll see that we do get back the original expression. So we're good. All right. Again, we're working through the questions here, but I see a simple trinomial. Start off with this. I have to multiply to get me a positive 25. Positive 25 means that both the numbers are positive or both the numbers are negative. So I have to add to give me negative 10. And already we can see that if I have to add to give me negative 10, I'm looking at both numbers that are negative. I can't add two positive numbers and get negative 10. And very intuitively, I'll see that the numbers are minus 5 and minus 5. So here I go x minus 5, x minus 5. And this, interestingly, can be written as x minus 5 the whole squared, as we'll remember, because we're multiplying x minus 5 by itself. So that would be our answer here. And we can see here that if we expand this out, we are going to get back that. Again, I'll leave the checking work to you. I don't want to, bore you too much while you're watching this video, but we've done the expansion. If you're not familiar with the expansion or having troubles with that, please review the first video or the video before this. We're going over prerequisites for factoring, the stuff that we did the last day of class. And we're just going to complete these things right here. It's a simple trinomial, xx. Again, I need to multiply to give me negative 90. So I'm looking for something that subtracts to give me negative 1. Don't forget the invisible 1 there. I'm looking for something that subtracts to give me negative 1. And I say subtracts because I know both of these, the two numbers are going to have opposite signs. So technically, I will subtract the numbers to give me negative 1. So 90, there's 1 and 90, there's 3 and 30, there's 9 and 10, and this 9 and 10, you'll see that if I subtract, I get negative 1, and obviously I need to have a negative 10 and a positive 9 so that I will get negative 1 and not positive 1 if I did negative 9 and positive 10. So I'm just going to put the numbers. Again, maybe I hadn't made that part clear. Once I identify what my two numbers are, plus 9 minus 10, I just put plus 9 in here, minus 10 in there. Right? Same way over here. Once I identify negative 5, positive 10, I just put negative 5, positive 10 for my binomial. Two numbers were minus 5, minus 5, minus 5, minus 5. So hopefully we see plus 4, minus 7, plus 4, minus 7 to fill that binomial. So x plus 4, x minus 7 will be my answer. So that's, hopefully we saw, that's what I was doing there. Again, this looks like, oh my god, what is this weird kind of thing? But it's actually the easiest one here because, again, two numbers that multiply to positive 300, and again, positive means both of them are the same, either both positive or both negative. This has to add to give me 301, so both of them are positive because it's a positive 301. And the first thing I would think of is 1 and 300, which do add to give me 301. So it's just x plus 1 and x plus 300 is my answer. You can expand this and check your work. And the next step is kind of important. I actually don't know off the top of my head what these blanks are supposed to be. I didn't really prepare. I should say I don't really know what the answers are. But regardless of what those answers are, the idea here is okay, sorry. Well, the form of the expression, the trinomial, is the same, ax squared plus bx plus c, where a can be not equal to 1. But again, this is usually how tricky trinomials are. That's like the definition of tricky trinomial, but this is actually not a tricky trinomial because a not equal to 1, but a can also be common factored. That's the key part here that we are going to be talking about. So a is not equal to 1, so you might think it's not a simple trinomial, but if you look at these three terms, you can let's look at the number that we can common factor out. We can common factor out a 3, which happens to be the a term. And therefore, this is, in fact, a simple trinomial. Because let's divide each term by 3. I get x squared minus 2x minus 12. And I can just keep this 3 outside and just deal with this the same way I would any other simple trinomial. Two numbers that multiply to negative 12. Let's see. So I have to subtract to get me negative 2. What is that? Oh, that's not right. 24 divided by 3 is 8. That's why it wasn't working. Two numbers that multiply to give me negative 8, sorry. And I have, because it's a negative 8, I have to subtract to give me negative 2, and I can automatically see that it's not 5 and 3, but in fact 4 and 2, because 4 and 2 multiply to give me negative 8, and subtract to give me 2, and the negative has to go in front of the 4, because it's a negative 2. So x minus 4 and x plus 2. And this is my final factored form. There's only one extra step that I did here, really, was factoring out a 3 because I could factor out. So whenever you see what appears to be a tricky trinomial, as in the a value or the coefficient of the x squared term is not 1, always check first if you can factor that out from each term here. Because if you can, then it does become a simple trinomial and it's much, much easier to work with than tricky trinomials. So again, we'll just practice some of these questions over here. Again, I see that I have a coefficient in front of my x squared. I check to see whether it can be factored out. It can, so I am going to factor that out. Now I have a simple trinomial. Two numbers that multiply to negative 24. Now let's think. Negative 24. So I have to subtract to give me a 2. So what can I do? So I'll always keep that in mind before you write out all your numbers. So I need to subtract to give me 2. So let's say 6 and 4 work. Those subtract to give me 2. And my 4 is going to be the negative 1 because I need a positive 2. So I have plus 6 minus 4 plus 6 minus 4. That's my answer. Again. Hopefully we can see that this is all still not too complicated. Again, this looks like a tricky trinomial because, whoops, my x squared term is not 1, but I can indeed, because after I check, factor out that 4 from all three of my terms. So I am going to factor out a 4, left with x squared minus x minus 30, two numbers that multiply to negative 30 and subtract to give me negative 1, 6 6 and 5, negative 6 plus 5. X minus 6, x plus 5. Again, you'll see here that I'm not actually writing out all the numbers. If you're not comfortable with just pulling out 6 and 5 from the top of your head, you can, as we were doing before, start writing, 130, 215, 310, 5, 6, and then checking each version to see if they subtract to give me -1. And I say subtract because your two numbers will have opposite signs, so you're technically subtracting their values, and they have opposite signs because their multiplication is a negative. This is actually a very interesting case because you'll see here that I kind of have a different scenario because I don't actually have an x squared and x and a constant term. I have an x cubed, an x squared, and an x term, which can easily be transformed into our familiar type by just factoring out an x, because an x is common from all three of these terms. Again, and the lowest power of x here is 1, which I can take out. And we'll see here that I couldn't really take out the x from these two questions because there was no x in this term. This term had 0. The constant term did not have any x's, so I couldn't factor that out. But here I can, and this is super easy. Two terms that multiply to 10 add to 7 is plus 5 plus 2. So this is x plus 2, x plus 5. Again, something I should have probably mentioned before, the order in which you do these things does not matter. It does not matter in the least. You can do that as x plus 5, x plus 2, or the way I've written it down here. It does not affect your answer. Here I see I have two problems. Well, one of this is an x cubed, so I should be able to factor out an x, and I can. But also that after I do that, this is still not a 1, this is a 5. So I am going to factor out the 5 as well, just so that after I've completed my factoring, I am left with something that looks like this, I believe. Because I've divided each part of the expression, each term in the expression, by 5x. So two numbers that multiply to -15. Let's see. So it's a -15, so I have to subtract to get a -2. And 3 and 5 do subtract to give me 2. -5, +3 would work. So 5x. Again, if you wrote 5 and 3 into -5, +3 this way, like I mentioned before, it does not matter whether you write x plus 3 times x minus 5 or x minus 5 times x plus 3. They're the same thing. But obviously, if you write x plus 5 times x minus 3, this is completely different and is not correct because here you're actually changing the numbers, and it won't give you back this answer. So hopefully we're seeing that. Okay, let's do some extension questions. Again, this is not that much more difficult because, again, first we see here that this does not look like a regular x squared 3x constant. It has an extra x minus 1 that's sitting over here, but that can be easily corrected by just factoring out that bracket, right? So what I'm left with here is if I divide each term by what I factored out, x squared plus 3x minus 10. Ta-da! Now I again have a simple trinomial. Multiply to -10, subtract to give me +3. That would be 5 and 2, +5, -2. That works. So x minus 1, x plus 5, x minus 2 is my answer. The same way over here. This one's a bit more tricky because you have an xy kind of going around. So the idea is I want to multiply to give me -14 y squared. So what has to multiply to give me -14 y squared, but add to give me -5 xy. So this one is a bit tricky in the sense that you kind of have to realize where it's coming from. So what I usually do is I ignore this y squared part for now. I just work with the numbers, same as always. 14 and 5, just ignore the y's for now. But we'll see here that, again, multiply to negative 14, add to negative 5. That's a negative 7, positive 2. That works. So I'm going to do the same thing I do as usual, x minus 7, x plus 2. But hopefully we'll see here that something is missing, and that something that's missing is the y, which I'm just going to put next to my numbers. Again, you might be like, oh, why did I just put that there? Hopefully we can see that I needed the y because now when I did like 7 times 2, before I used to get negative 14, but now I need negative 14y squared, which means I need the two y's there to multiply to give me y squared. Hopefully we're seeing that that's what we're doing. So yeah, so that's how we figured that out. Well, not figured it out as much as I told you, and you will now know how to do these kinds of questions. But that being said, I will leave you to the homework for today. Again, I hopefully you're kind of imagining if we were in class, you would have probably gone around and done some questions on the boards that you were that we're like used to doing. But unfortunately, we obviously cannot do that. So you're gonna have to do. I'm gonna count on you to do the practice homework questions on your own. So yes, you're gonna do that. What I will do is actually I'm gonna kind of give you a question to do for homework, and all of you are gonna do that one question. If we are continuing with this model, I will come up with like different kinds of questions and make it more like class. But for now, we're just gonna um, sorry, give me a second. So if you have indeed made it to the end of this video, congratulations for being an excellent watcher of YouTube videos. And this is the homework question that you are going to solve and post the answer in the comments below. You are going to do 4x squared minus 28x plus 24. I want you to factor this and post a comment in the section below with your name if you're if it's not incredibly obvious what your name is from your username on YouTube. So yeah, that's that. Here's your homework. Again, so I will leave that to you. Yeah, I'll see you in the next video. I mean, talk to you at least. So peace.